I'd like to introduce Ray Bonilla, one of the three chairs of ECA Bay Area, who's with Elevance Health and also a city council person for City of Hayward. Ray.
Thank you so much, Mark, and welcome everybody to our Winter 2025 Earthquake Country Alliance workshop. We have a pretty full agenda in store for you today. I think you're going to get a lot of benefit from the agenda and the program that we'll go over with you in just a little bit. But before we jump into today's program, we always like to remind people of the grassroots power of the Earthquake Country Alliance. It's made up of 4,000 public and private sector leaders from across California, particularly in the Bay Area. They're statewide committees that develop resources and deliver programs to help all of us continue to advocate and strengthen earthquake preparedness and tsunami preparedness across the state. The California Office of Emergency Services provides ECA with mitigation funding to help carry out the activities of this alliance. And we are headquartered out of USC, and the statewide California Earthquake Center administers the Earthquake Country Alliance. So just a little bit about us, there's five different geographic chapters that you see there in the map off to the right. Today you are a part of ECA Bay Area, and without any further ado, this coordinating work across the Bay Area is done in partnership with Jeff and with Dina. So I'll invite Dina to introduce the co-chairs of the coordinating committee. Dina?
Great. Thanks so much, Ray. Good morning, everybody. So excited to see so many people on and still joining. So welcome. As Ray said, we have a full agenda this morning. But we also have Jeff Arith, who is with San Francisco International Airport. Good morning, Jeff. Again, I'm Dina Gunning. I'm with the Central County Fire Department here in San Mateo County. And we are your Bay Area co-chairs for the Earthquake Country Alliance. So I'll talk a little bit about our coordinating committees and the different opportunities that we have for you to join us. We're a wonderful group of people. We get a lot done. And we're really excited to have folks join us. And we're always looking for new members for our coordinating committees. We have a communications coordinator, we have events bureau, we have a media bureau position that's currently open. So if you're interested in that and you have some media experience, we'd love to have you on board. Membership and participation bureau, our regional workshops coordinator. So we have so many people that join us, and we'd love to have somebody else in that role now that Jeff has jumped up into our one of our co-chair roles. So we would love some help on that. But we really come together quite a few times a year, and we have these subcommittees that meet. So we are really again, going back to those grassroots, we are the Bay Area region, and these are all of the ways that we support the Earthquake Country Alliance Bay Area region and the regions throughout the state. So welcome, everybody. And with that, I will turn it back over to Ray for the first introductions of the presenters. Or sorry, turning it back to Jeff. Jeff's going to go over the agenda this morning. Jeff, back to you.
Of course. Thank you. Thank you, Dina. Thank you, Ray, and thank you, Mark. And again, as echo everyone for being here, thank you, welcome, and we hope that you enjoy and get some good information and some preparedness information out of this workshop today. We will start with an overview of tsunami hazards as we get into our agenda here. I think a lot of people have some questions about what happened on December 5th. And hopefully we get some answers and look at some of the, not only technology, but some of the sciences of that. After that, and that's going to be with Todd Becker and Jay Patton coming up here. We'll introduce them here momentarily. After their presentation, we will have a quick quake break. This will be about 5-minute presentation, which is kind of a standing agenda item for the Earthquake Country Alliance. Basically a report of the recent earthquakes and even tsunami things. And this is going to be by Dr. Curtis Bodden who is with the USGS, and we'll get into that here by 11:05. At 11:10, we're going to have a very informative presentation by the Director of Emergency Management of the Marin County Office of Emergency Services, and that is Stephen Torrance. We look forward to hearing from him. He's going to go over the Marin County earthquake and tsunami hazards and how they responded to the December 5th event. After him, we will have a Mark Benthing, our executive director, will go over the current activities this year in 2025 and opportunities and some hopeful events and maybe opportunities for you, all of you, to make any announcements or any events or things going on. We'd love to hear from you and see what's going on this calendar year 2025, and that'll take us to about noon. Again, thank you all for joining us, and I will turn this over to
Hey Jeff, just
Ray.
1 second.
Yes, sure.
Sweecar, I saw that you had your hand raised for a moment. I just wanted to know if you did have any question or already.
I did. I think when they were talking about opportunities and roles that were open, I think if I had got your name right. I'm Sweecar Simpson, by the way. I'm the risk manager at Santa Clara Unified. I wanted to know, what are those roles? Are they defined? What the role responsibilities are? I'd like to know if I want to get involved.
Excellent.
Yeah.
Yeah, we do have a sheet that describes them, and we also have part of the survey for today's that we'll show the link to and a QR code for, has a place where you can indicate interest in participating and provide your contact information, and we'll follow up with you.
Great. Thank you so much.
Continue those roles. Great question, and great that you're interested, and we'd love to have school participation on the coordinating committee for sure.
Thank you.
Okay.
Think over to Ray.
Yes, so with that, we'll jump right on into the first presentation of today's program, which is an overview of the tsunami hazards, including a review of the December 5th, 2024 Cape Mendocino earthquake and tsunami warning. We are joined by two renowned speakers in this area, Todd Becker and Jay Patton. I'll share a little bit about their background, and then I'll turn it over to these two gentlemen to get us started. Todd Becker is a geologist and emergency management specialist with over 20 years of experience in public and private sectors, working with both state and local governments and for private sector organizations. At the Cal OES Tsunami Program Coordinator, he coordinates programs and projects supporting tsunamis and earthquake risk reduction throughout California, including chairing the National Tsunami Hazards Mitigation Program's Mitigation and Education Subcommittee. Co-presenting with him today is Jay Patton, who is also a geologist who has been studying the tectonics of the Cascadia subduction zone for over 30 years. He specializes in onshore and offshore paleoseismology, which is the study of prehistoric earthquakes. I wasn't really sure what that was, but now I know, and sea level rise. Patton is an engineering geologist at the California Geological Survey and works on seismic and tsunami hazards. He serves the state of California as a California Science Advisor to the National Tsunami Hazards Program, as well as co-chair for the Mapping and Modeling Subcommittee. I don't know if there are two better speakers to talk to us on this topic today, but we're excited to welcome both Todd and Jay to today's conversation, and we'll turn it over to them to get us started. Welcome, gentlemen. All right. Who wants to kick us off?
Jay, you're muted, and just I know
It's me. I'm sorry.
and you're sharing your slides.
Yeah. That's funny. I was waiting for Todd. And I'm like, oh, wait, no, I'm going first. Just got to start my talk. Now we'll share it.
And I know I shared this with our presenters yesterday. There's a request from, I think it's always a great idea to, as best as possible, to describe the imagery for people who may be visually impaired to be able to follow along better. So as best you can, add that into your presentation.
Absolutely. So Todd, can you see my presentation slide?
Yes.
All right, thanks. Thank you for having me here to present an overview of the tectonic background of the 5 December magnitude 7 earthquake offshore of Northern California. And I'll make this slide deck available to anyone who wants it so that people can go back and review many of the details that I don't have time to completely discuss today. And my email is listed in the lower right corner. This is a simplified map of Earth's principal tectonic plates, thin layers of the Earth that move around in different directions. The red arrows indicate the direction of relative movement at the plate boundaries where these plates meet each other, and California is inside that white box. There are 3 types of plate boundaries, and these diagrams represent them. Divergent, where plates move away from each other; convergent, where plates move towards each other; and transform, where plates move side by side like the San Andreas Fault. Let's take a brief look at the Cascadia subduction zone, a convergent plate boundary that affects California. While the Mendocino Fault earthquake is not directly related to the subduction zone, the understanding of this tectonic setting provides important context. Here on the left, we have a map of California, Oregon, Washington, and British Columbia, where the Gorda, Juan de Fuca, and Explorer oceanic plates subduct beneath the North America continental plate. We won't spend time discussing the tectonically controlled vertical land motion as represented by the 2 cross sections in the upper right, though this animation in the lower right does show how subduction zones can generate tsunami. We can see that the 5 December 2024 Mendocino Fault earthquake is shown on the map as a yellow star. This earthquake ruptured a fault that is a transformed plate boundary like the San Andreas Fault, and where the San Andreas, Mendocino, and Cascadia subduction zone faults meet is called the Mendocino Triple Junction. There are different types of faults, and the 5 December earthquake was on a strike-slip fault. Strike-slip faults move side by side as shown in the diagram. Things that cross the fault like a stream may be offset by the fault during an earthquake. Here we see, yes?
I'm sorry, just to interrupt for a moment. There's in the newer version of Zoom, you might, some of you may be having an issue where you're not actually seeing the slides. There may be a tab at the top of your screen to switch between seeing the video and the slides. You should see a tab called J Patton's Screen, and that's where the slides are. So
Thanks, Mark.
hopefully that addressed the issue. I heard from a couple people. Continue, Jay.
Thanks, Mark. So, clickety click. So here we see a fence near Point Reyes, north of San Francisco, that was offset during the 1906 San Francisco earthquake on the San Andreas Fault, indicated by the yellow dashed line. Note how the once through-going fence on the opposite side of the fault has been displaced by the earthquake to the right. We call this a right lateral strike-slip fault. After the 2019 Ridgecrest earthquake, the CGS joined the USGS to document field evidence for the earthquake. We set up the California Earthquake Clearinghouse in Ridgecrest and reported into the clearinghouse each day. This road was offset during the earthquake. The red lines show the edge of the road. Can you tell if this was a right lateral or a left lateral strike-slip earthquake? Which direction did the earth move on the other side of the fault? Yes, it was a right lateral strike-slip earthquake. Another example of right lateral strike-slip offset here of a stream channel. Note how the red line representing the edge of the stream channel is offset to the right. We discovered some grooves on the earthquake fault shown in this photo, formed when the fault slipped. These grooves tell us how the fault moved during the earthquake. We can see that the fault mostly moved horizontally, but it also had some vertical motion. The Mendocino Fault is a right lateral transform plate boundary separating the Gorda and Pacific plates as shown on the map. There have been historic earthquakes along this fault system. While strike-slip fault earthquakes can generate tsunami, especially if the earthquake slip is shallow or surface rupturing, they are generally smaller in size compared to subduction zone earthquake-generated tsunami. Excuse me. This map from Dr. Lori Dengler et al. Shows earthquake mechanisms associated with the 1994 7.1 Mendocino Fault earthquake and aftershocks. These mechanisms look like beach balls. The 2024 magnitude 7 earthquake is the largest earthquake along the Mendocino Fault since 1994. What do the checkerboard-looking beach balls represent? Yes, strike-slip earthquakes. These 6 earthquakes all have strike-slip mechanisms that can be interpreted to represent right lateral strike-slip earthquakes on the Mendocino Fault. In this map, which has lots of information on it, I plot aftershocks in the center from the 2024 earthquake in orange and aftershocks from the 1994 earthquake in green. In the upper right map, we can see modeled and observed intensities for this earthquake, the 2024 earthquake. The map shows intensity observations up to MMI 7.9, severe shaking almost. The USGS ground failure maps in the lower right show the probability of earthquake-triggered landslides on the left and earthquake-induced liquefaction on the right. We'll look at these later. Zooming in on this larger scale map includes the aftershocks and earthquake mechanisms from this 7.0 earthquake sequence. Most of the mechanisms show that these events are largely right lateral strike-slip fault earthquakes. They all look like those beach balls. This illustration, showing a cross-section of the Earth in the ocean, provides some background terminology for tsunami waves. Wave height is the vertical distance between the crest or peak and the trough of the tsunami waveform, while amplitude is the vertical distance of the water surface elevation above the ambient water surface elevation. And finally, in the upper right corner, run-up height is the maximum elevation onshore that the tsunami reaches. So there was a tsunami observed at the North Spit and Arena Cove tide gauges as shown on these plots with time on the horizontal axis and water surface elevation on the vertical axis. The dark blue line is the tidal forecast, the medium blue line is the tide gauge observation, and the light blue line is the difference between the forecast and the observation. This signal represents the tsunami and any other background waves. The tsunami was small, on the order of centimeters in size. There were observations that the north part of Humboldt Bay emptied and filled at least 3 times. This video shows the change in water surface elevation in excess of 1 meter, a range not recorded on the tide gauge. This appears to be evidence for a seiche driven by resonance from the seismic waves, but we're still working on this. The CGS Strong Motion Instrument Program, SMIP, runs strong motion seismometers statewide as shown on the map on the right. Along with other network contributors, these data are submitted to the Center for Engineering Strong Motion Data. Anyone can download these data for visualization or analyses, and the plot on the left shows the daily download for these data following the earthquake. The ground motion model on the left, derived estimate of peak ground acceleration, is plotted as a blue line with uncertainty range in dashed blue. Peak ground acceleration is the vertical axis, and distance from the earthquake is the horizontal axis. Instrumentally recorded ground accelerations are plotted as black dots. Note how the observed ground accelerations are higher than the model estimate within 100 kilometers of the epicenter. The USGS simulation of seismic waves may help explain these higher accelerations due to the amplification of ground accelerations within the Eel River sedimentary basin. SMIP engineers have evaluated the ground motion data from sensors in this bridge near Rio Del. The diagram on the left shows the locations for the seismic sensors on the bridge, and the next slide includes an animation from sensors in the bridge decks shown in the photo at the right. This animation shows the accelerations recorded along that section of the bridge. The 8 plots on top show acceleration in units of g, gravity, or gal. Each plot has a different vertical scale. The 2 stations on the right show accelerations exceeding 1g, the force of gravity on the Earth's surface. Following significant earthquakes and tsunami, the state geologist Jeremy Lancaster sends geologists into the field to make direct observations of fragile and perishable features that are evidence of earthquakes and tsunami. These observations are recorded on mobile devices and included in a GIS database for the event. The CGS used information such as the USGS ground failure maps shown on the left to prioritize regions for these field investigations. Areas with a high chance for landslides are shown in red to purple colors on the left, and areas with a high chance for liquefaction are shown as red to purple in the map on the right. Kate Thomas at the CGS is the chair of the California Earthquake Clearinghouse, and a virtual clearinghouse was activated during this event. More information about the California Earthquake Clearinghouse can be found at californiaeqclearinghouse.org. This map shows the locations of observations made from the CGS event response team, and symbols, as shown in the legend, represent the type of observations made. During the event response, the CGS has staff scouring social media for observations, and these data are also uploaded to the database with symbols of colored flags on the map. All of these observations are viewable at the Cal-OES State Operations Center via an interactive dashboard. This allows emergency response to be educated about the physical impacts of these natural hazards events. At the location shown on the map, we can see landslide headscarps in the photo on the left. This is evidence for earthquake-triggered gravitational collapse of the road prism. At this location on the map, there was damage during the 2022 Ferndale 6.4 earthquake, and the county road department patched the cracks in headscarps. The photo on the left shows that these cracks, etc., were reactivated during the Mendocino Fault earthquake. Gathered by the social media team at the CGS, these are photos posted by a local news organization to their social media page, and these were taken at the Market and Shelter Cove shown on the map. And these photos show earthquake-triggered landslides along the coastal bluffs near Centerville Beach shown on the map. Someone might ask, are earthquakes causally related? In general, there are several ways seismologists think that earthquakes on one fault can trigger earthquakes on another fault. Dynamic triggering. This can happen when seismic waves from a source earthquake travel across another fault and trigger an earthquake on that receiver fault. Static triggering. This can happen when a source earthquake increases the stress in the adjacent lithosphere, the crust, leading to rupture on a receiver fault. Seismologists conventionally think that this type of triggering is limited to within 2 to 2.5 times the source earthquake ruptured fault length from the source fault. Using fault scaling relations in the upper right corner, where we have plots comparing earthquake magnitude and surface rupture length on the horizontal axis, the Mendocino Fault earthquake may have ruptured a fault with a length of about 40 kilometers, so might affect earthquake faults up to about 100 kilometers away. Well, Savilkin et al. Used modeling software to evaluate the static changes in Coulomb stress as exerted onto receiver faults by the 7.0 Mendocino Fault earthquake. This is static earthquake triggering analysis. On the map on the left is shown changes in stress imparted onto faults like the San Andreas Fault, showing the San Andreas Fault located onshore in this location has an increased stress in red. The areas in blue designate areas of decreased stress. On the map on the right is shown changes in stress imparted onto faults like the Cascadia subduction zone, showing that the megathrust has an increased stress. These changes in stress are very small compared to the overall stress budget for earthquake faults. Therefore, faults need to be already highly stressed for them to be triggered like this, and it is very difficult to know the current state of stress on any earthquake fault. And with that, I will wait to discuss questions after the next talk. And thank you for your time. I will stop sharing. Awesome.
Thank you, Jay. A reminder to, if you have questions, you can put them into the Q&A section, which you'll find in the More menu on your toolbar. And thank you, Todd, for gearing up here. Go ahead.
All righty. Sounds like you can see my screen. All right. Thank you, everybody. Good morning. Thanks, Jay, for that great presentation. And I think Jay will be submitting a quiz for you all at the end of this, so be prepared for that. Hope you were paying attention. But thanks to Ray for that great introduction, so I can skip some of that. I did want to note that, my agency, the California Governor's Office of Emergency Services, Cal OES, we're the emergency management side of our California Tsunami Program, which is the collaboration between Cal OES and the California Geological Survey, CGS, and we partner with the National Weather Service and some of the other agencies that you see their logos here, FEMA, USGS, through our National Tsunami Hazard Mitigation Program to lead the state's efforts to assess tsunami hazard and mitigate tsunami risk throughout California's communities. One of our other key things we rely on is working with groups such as the ECA to help get that word out about tsunami hazard and how you can be more informed and prepared for the next earthquake or tsunami event. So thank you, ECA, for having us here today, and thank you all for being here today. And with that, I will roll into my slides. To follow up on Jay's talk, I'm going to continue with some discussion about the December 5th earthquake and tsunami warning. Then I'm going to transition into reviewing some tsunami facts and things we can do to be more prepared for future tsunami events. The images on this slide include a shake map from the December 5th event showing the shaking intensity of that magnitude 7 earthquake and the mobile phone notification displaying an emergency alert for a tsunami warning. So Jay covered the details of that magnitude 7 earthquake that occurred off the California coast near Cape Mendocino at 10:44 hours local time on December 5th. Just prior to shaking, earthquake early warning alerts were successfully issued for this event. Alerts went out through the MyShake app on Apple and Android phones. Android phones also automatically received the alert. And then earthquake early warning was also issued via the wireless emergency alert because the earthquake was greater than magnitude 5.0, and based on the shake alert algorithms was sent to people who would experience shaking greater than an intensity of 4 or light shaking. Many people throughout Northern California into Southern Oregon and some in Nevada reported feeling this event. I can attest to the success of the earthquake early warnings as I was at my desk just wrapping up a meeting that morning in Eureka. I work on out of the National Weather Service in the middle of Humboldt Bay here. I was having a snack, saw the alerts, crawled under the desk with my snack. And then, it got really real as the shaking began and intensified. But it was a great example of the success of those earthquake early warning alerts because it allowed me to take that protective action. So the images on this slide include a table showing the earthquake early warning alerting thresholds for California, including intensity, shaking level, and alert types. And the other image is the U.S. Community Internet intensity map for that magnitude 7 earthquake that shows the did you feel it reports for shaking intensity levels across the region.
Carriers, but don't worry, we've got more than that going for us.
All right, picking up a little background noise. All right, so now a little about the tsunami alerts and where they originated for this event. There are 2 tsunami warning centers operated by NOAA and the National Weather Service. We have the National Tsunami Warning Center in Palmer, Alaska, which has reporting responsibility for the continental U.S. and Canadian coastlines. And we also have the Pacific Warning Center in Hawaii, which has alerting responsibility for Hawaii, the U.S. territories, and some international partners. In California, we need to pay attention to the alerts coming from the National Tsunami Warning Center, or NTWC for short, in Palmer, Alaska. Immediately after detection of the earthquake, the duty scientists at the National Tsunami Warning Center in Palmer, Alaska went to work evaluating that earthquake to determine if a tsunami alert was to be sent for this event. The duty scientists only have about 5 minutes to determine what alert needs to be sent based on review of the initial seismic waves and preliminary location of the earthquake. The images on this slide include a world map with boxes highlighting the area of responsibility for the tsunami warnings and an image showing the duty scientists analyzing the earthquake at the National Tsunami Warning Center. And those are real people that we know that, that work out of that office doing that great work that they do. Okay, so on December 5th, in accordance with the National Tsunami Warning Center Operations Manual and the initial location of the earthquake, a tsunami warning was to be issued for the coastlines of California and Southern Oregon nearest the earthquake. The tsunami warning needed to extend to the nearest breakpoints, which are predetermined locations within the National Weather Service used for determining the alerting areas. Based on that National Tsunami Warning Center protocol, the warning needed to extend about 150 miles out from the earthquake location. Since this distance exceeded the breakpoints at the Gualala River and California-Oregon border, the warning was then extended to the next breakpoints, which were Davenport, California, and Douglas Lane, Oregon. The image on this slide shows a map of California and Oregon coastlines, showing that initial and final earthquake location and the breakpoints along the coast. So the tsunami warning was then issued through a wireless emergency alert for all the coastal counties shown in red in the image. Due to limitations with the alerting system, the wireless emergency alert is distributed county-wide within the affected counties and not just to the areas with identified tsunami hazard. The tsunami warning bulletin number 1 included the potential arrival times for some Northern California locations. From the time of warning, first wave arrival would have been about 20 minutes to Mendocino County, 30 minutes to Del Norte County, and about 1 hour, 20 minutes to San Francisco. The image on this slide includes some of the text from that National Tsunami Warning Center bulletin number 1, a map of California and Oregon showing those red highlighted areas where the wireless emergency alerts went out, and the mobile phone notification displaying the wireless emergency alert for that tsunami warning. Bulletin number 2 was then issued at 11:24 hours by the National Tsunami Warning Center, about 35 minutes following the initial warning. There were no significant changes in this message for bulletin number 2. The earthquake magnitude was revised to magnitude 7.0 at that time. Bulletin number 3 was then issued at 11:54 hours, just over an hour after the initial warning, noting that the tsunami warning was canceled. Bulletin number 3 came out just following the National Tsunami Warning Center conference call that occurred at 11:45 hours that day, after they had determined there were no impactful tsunami waves for this event. The image on this slide includes text from both that bulletin number 2 and bulletin number 3 from the National Tsunami Warning Center. So following the December 5th earthquake and tsunami warning, California has been conducting extensive after-action review with local, state, and federal tsunami program partners to better understand what went well that day, areas of opportunity for improvement, and key priorities for this tsunami preparedness efforts in the state. There were a lot of lessons learned, but I want to highlight a couple things regarding tsunami preparedness from a community outreach and education perspective today. It was observed that communities that had conducted tsunami evacuation drills fared better during the event, highlighting the importance of regular training and exercises. The event underscored the need for enhanced public education about tsunamis, including awareness of tsunami hazard zones and what to do during a warning. Many people were not aware if their homes, places of work, or schools were in a tsunami hazard area prior to the warning, causing confusion, panic, over-evacuation, and failure to evacuate in some situations. Building on these lessons from the December 5th tsunami warning event, the California Tsunami Program will continue to enhance our statewide tsunami preparedness, response, and resilience with key priorities to include increasing the public baseline awareness of tsunami hazard areas and encouraging evacuation on foot. Additionally, the California Tsunami Program is focused on the continued support and strengthening of local partnerships so we can continue together to ensure tsunami plans are in place and messaging is prepared in advance. The images on this slide included a tsunami hazard warning sign and an infographic with 3 sections providing earthquake and tsunami safety instructions. So to continue with this part of the presentation and give you all a little break from me, I would like to show you this video. I really find it's fun and entertaining. It's available on the web, so it's a great thing for people to share, use in any of your events. So we watch this to start off, and then we're going to go into some of the concepts in a little more detail for the remainder of my presentation. And I guess, Mark, I should have shared my volume, but chime in if you guys can't hear it.
Please share the sound of the video, otherwise we don't get to hear it at all.
Right. Yes, I share that. Thank you, Sheila. All right.
We're hearing it, Todd.
Okay, fantastic. Oh, did I pause it? I'm sorry.
Yeah.
I don't usually make tsunamis, but when I do, I prefer to use earthquakes. Last name Nami, first name Sue. People don't understand tsunamis, and I'm here to fix that. If you feel shaking, that's an earthquake and a tsunami warning sign. Get away from the water. The first wave could be the smallest. It's unbecoming, but destruction's my middle name. Hence, the next wave could be bigger. Nothing compares to how a tsunami actually feels. You might see water sucked out, like a really fast, really low tide. You might hear a loud sound, like a train in the ocean. Recognize these signs. A tsunami could be coming right now. You need to get to higher ground, uphill or inland. See, I'm already making a difference. What are you waiting for? You won't get a second warning sign? Go uphill because I can't. That's just between you and me.
This is the part I always have trouble getting off the video next. Okay, I think. All right, there we go. I hope you all enjoy that. Like, honestly, that that video makes me smile every time. It's serious stuff, but I love the way they presented that. So now let's review some tsunami facts. Tsunamis are most commonly caused by earthquakes, but are also triggered by submarine landslides, volcanic eruptions, explosions, and very rarely meteor impacts. A tsunami is a series of water surges, usually caused by an earthquake beneath the seafloor. Tsunamis can come from earthquakes nearby or thousands of miles away. Most tsunamis are only inches high in the open ocean, but large tsunami may reach heights of 20 to 50 feet along the coast, and in some isolated areas, even higher. Areas at greatest risk are beaches and harbors. Typically, only major tsunamis flood the land and or travel up river channels. Sometimes the first sign of a tsunami is drawdown, an unusual lowering of the ocean, exposing the seafloor. The water will surge back quickly, much faster than you can run. However, not all tsunami are preceded by the drawdown. And tsunami can be tricky. The first surge may arrive in minutes if the source is close, or take many hours for earthquakes far away. The the first surge won't always be the largest. Successive waves may be spaced irregularly from minutes to an hour or more. Just when you think the tsunami is over, a larger surge may arrive. Tsunami danger can last for many hours and sometimes more than a day. Tsunami may appear as a rapidly rising tide, a sloping wall of water, or a chaotic mass of swirling water, often choked with debris. No two tsunami are alike. And the image on this slide was a tsunami hazard warning sign, and then a diagram is illustrating how the earthquake causes tsunami, where the seafloor at the location of the earthquake moves from that earthquake, and the seawater is displaced from that. And I think Jay had some great images on that too. So why does California have tsunami hazard? The tsunami hazard exposure exists for those living, working, or playing along our beautiful coastline. The tsunami hazard is primarily due to the California coast being situated along active fault lines and the proximity to the Pacific Ring of Fire, where tsunami generating earthquakes can occur. Remember, tsunami can come from earthquakes nearby or thousands of miles away. The image on this slide includes a world map showing the Pacific Ring of Fire and major ocean trenches, and a map showing the Cascadia subduction zone off the coast of the Pacific Northwest. So how do we know where the tsunami hazard is in California? The California Geological Survey, along with my office, the Governor's Office of Emergency Services, some of our university partners, and local agencies have mapped California's tsunami hazard areas. The maps were updated within the last few years using the best currently available scientific information and represent areas that could be exposed to tsunami hazards during a tsunami event. The tsunami hazard area maps for California are available at the California Geological Survey website, tsunami.ca.gov. A screenshot of the webpage displaying the California tsunami hazard area maps is shown in this image. The tsunami hazard areas are the yellow highlighted areas along the coastline. You can enter an address or use location features and zoom in on these maps for more details. Again, yellow areas are the hazard area, green areas are safe areas. In case of a tsunami warning, natural or official, you would need to go from the yellow areas to the green areas on foot. Remember to know your zone by locating where you live, work, or recreate before that next tsunami. And the image here includes an additional screenshot of the web page, zoomed in and displaying the California tsunami hazard area maps in one of our Northern California coastal areas, and also included is a graphic that illustrates moving from the yellow hazard area to the green safe area. So where have tsunami impacted California in the past? About 45 tsunami have been recorded in California within the last 100 years. Not all of those have been in fact impactful and caused damage, but tsunami may be more common than you would think. Some tsunamis have been very impactful in California, causing significant damage and loss of life. The Great East Japan earthquake and tsunami in 2011 caused hazardous currents and surges in California, resulting in over $100 million in damages to marinas and harbors, and also including one loss of life. The volcanic eruption in the Kingdom of Tonga in 2022 produced tsunami flooding along the coast of California, which generated strong currents and caused about $10 million in damages. There were also many close calls where first responders had to rescue people from the water, but unfortunately, no fatalities occurred during that event. These two events were also, unfortunately, not the worst case possible tsunami events we could have in California. So this slide has images of a photograph of a fishing boat grounded after a tsunami in California, and also a photograph of the harbor. This is the Crescent City Harbor, I believe. Yes, after the 2022 or 2011 Great East Japan earthquake and tsunami. So how do we recognize and understand the tsunami warnings? I want to talk a little bit about how we recognize those and get these warnings. Two ways to know if a warning is coming are natural and official warnings. Natural warnings are when the tsunami source is close. Ground shaking, the ocean roar, or water receding unusually far are all nature's warnings that a tsunami may be coming. If you observe any of these warning signs, immediately walk to higher ground or inland. Don't wait for an official notification. A tsunami may arrive within minutes, and damaging surges could continue for many hours. Stay away from tsunami hazard areas until officials permit you to return. Official warnings are for when the tsunami source is farther away. Official alerts are issued on cell phones, TV, radio stations, and NOAA weather radios. You need to move away from the tsunami hazard areas and tune into local radio or television stations for more information after an event like that. Prior to natural or official warnings, you will want to know your tsunami zone so you can take immediate action if necessary. And the image on this slide is an infographic with information on the official tsunami warning signs and natural tsunami warning signs. So what are the official tsunami alerts from the National Tsunami Warning Center? This graphic shows the tsunami alerts from the tsunami warning centers. The National Tsunami Warning Center monitors events around the Pacific that might produce a damaging tsunami on the California coastlines. Bulletins are issued in 5 minutes or less following the West Coast or Alaska earthquakes, and generally within 10 minutes after faraway earthquakes. Typically, a tsunami information statement alert is issued by the tsunami warning centers when an earthquake has occurred that is large enough to be felt on or near the coast. Fortunately, in the majority of cases, the tsunami information statements are issued to indicate that there is no threat of a destructive tsunami and to prevent unnecessary response actions. A tsunami watch may be issued when there's time to assess the tsunami threat and there is a chance a warning or advisory could be issued. You will need to wait for further guidance from officials and updated alerts. Two types of alerts will require immediate action. The tsunami advisory. That's where flooding of dry land is not expected, but beaches, harbors, and low-lying coastal areas may be damaged by strong currents and need to be evacuated. The tsunami warning. On-land flooding and powerful currents are possible. If you hear that a tsunami warning has been issued, evacuate tsunami hazard zones. Remember that official warnings are for tsunamis coming from far away. When the tsunami source is close, feeling the ground shaking may be the only warning. Before you get these alerts, again, it's time to know your tsunami zone so that you can immediately head to high ground or inland away from the coast if necessary. The image on this slide includes an infographic of the official tsunami alerts that I just described. Oh, wrong way. All right. So I want to mention where people can go to get tsunami event information. This slide shows the homepage for the tsunami warning centers, which displays current tsunami alerting for both the tsunami warning centers, the Pacific Tsunami Warning Center and the National Tsunami Warning Center. Tsunami alerts are distributed through X and Facebook, and if you go to the website, the National Tsunami Warning Center website here, you can get more information about how to sign up and get those alert feeds. When you're signing up for the alerts, just remember for California, it is the National Tsunami Warning Center in Palmer, Alaska, which has alerting responsibility for the continental US and Canada. And it's the Pacific Tsunami Warning Center that has the alerting responsibility for all the other areas. This image on the slide includes a screenshot of the NOAA National Weather Service Tsunami Warning System website. And then finally, I want to wrap up my presentation today with a couple takeaways. First, know your tsunami zone. You probably heard me say that a few times. Like I said, it was one of those takeaways from our December 5th event. And it's something we want to keep, emphasizing as we get out there and talk with everybody. You can go to tsunami.ca.gov and identify the zones for where you live, work, go to school, or recreate. Know your tsunami zones before you feel the earthquake or get an official tsunami alert. Then, the most important things to remember about earthquake and tsunami can be summarized with this image. Don't move during earthquake shaking. Stay where you are, drop to the ground if you are able, cover your neck and head with your arms, and if under a table, hold on. Are you in a tsunami zone? Shaking is your warning that a tsunami may arrive in minutes. Head to high ground or inland as soon as it is safe to walk. When in doubt, drill it out. And stay away from the coast until officials allow you to return. Dangerous surges could last for more than a day. And just remember that preparing helps reduce loss and helps bring us peace of mind for these events that we can't control. And the image on this slide was an infographic with three sections providing the earthquake and tsunami safety instructions just described. So with that, thank you all for your attention today. My contact information is included there. And remember to know your zone and contact us for any more information. With that, I will stop sharing.
Thank you very much, and Jay also. We have quite a few questions and comments and things I want to run through at the time we have here. We have about 10 minutes before keeping on our schedule. Just a point that we will be sharing through the same place where you went to register at earthquakecountry.org/BAWI 25, Bay Area Winter 25. And we'll have links to that also, but that's where we'll be putting the recording on a link to the YouTube recording of today's full workshop, and also a PDF of the slide set overall. There also was, I believe, you'll see in the chat, and also links to Jay and Todd's email addresses if you want to reach out to request the actual slide sets for use. So you'll see that. And let me just look at other. Please do, as we go forward, put as you all are doing now, put your questions in the Q&A. I'm just looking for ones that in the chat first. One that's in both. Oh, and also in the Q&A, look for answered questions by text. So there was a question about, see if it's been answered there, about being in the Bay Area and the evacuation zone, like if you're in Alameda and the issues there with low-lying areas around the Bay. I believe there's, I'm not sure if I made the Q&A. Can a local earthquake in the Bay Area cause a SAISH in the San Francisco Bay, and how likely is it? Any historical evidence, and how concerned should Bay Area emergency managers be? Jay?
All right, so for a SAISH, yeah, I'm sure it's possible. I don't know, how possible, but a SAISH would probably be on the order of, a meter or maybe 1.5 meters of, water surface elevation fluctuations. And so at that scale, the tide would have a big factor. So at low tide, that would probably have no impact for people on land, though it would possibly generate strong currents in the harbors. At high tide, it would generate, stronger currents in the harbors, and it could flood some of the levees maybe, but certainly not, vast areas where people are, living and working. And so part of the, one of the other questions that is related to this is, if I'll go ahead and answer, is what are the wave height estimates for a tsunami in South San Francisco Bay, especially towards SSF and Millbrae and Burlingame? So Mark would like to answer. Basically, on the order of, 1 meter to 2 meters, we think, for a tsunami coming from, Cascadia or Alaska, and places like Santa Clara, San SFO. Most of the tsunami models don't actually flood on land very, very much, like in the San Jose area. As long as you're not along the levees, along the salt marshes and the salt ponds, you're going to be fine. So that's, so it's a much smaller wave. Um, what we've noticed from the wave models, so we have probabilistic tsunami models. So basically, we have 1,000-year tsunami model. When this is, kind of like you've heard of the 100-year flood. Well, we have the 1,000-year tsunami model, and that's what the tsunami hazard area maps are based on. And so, looking at the 1,000-year tsunami model, the tsunami size, the amplitude, the height of the water above the ambient background water level is on the order of 4 to 6 meters on the outside of the Golden Gate. But once it goes inside the Golden Gate, the size of the tsunami goes down to 2 to 3 meters roughly. And so and then once you go into the South Bay, it gets much smaller. Some of the areas like in San Rafael, Richardson Bay, those areas in Marin, those areas, it's 3 meters, 2 to 3 meters in size. And so there are large areas of low-lying land that could be inundated. That's represented by those THA maps. So I hope I was able to answer those questions.
Thank you, Jay. Another question we have is from Ann Schneider. Given the number of hotels in the tsunami zones, with people from all around the world staying there, is anyone working with hospitality industry to tell visitors what to do? I'll start to say that we have done some outreach and really work to identify those hotels that within the refined tsunami zones. We need to kind of update that as the maps have been updated, and in some places reduced in terms of the extent of the area. That would remove perhaps some of those hotels from the zone. We are planning a business-oriented, which would be geared towards hotels too, of course, webinar for Tsunami Month during Tsunami Week, likely either the 24th or the 25th. And definitely want to hope that we'll have all matters of all types of business participate there. But certainly it's a key issue. And we've seen that around the world during tsunamis, Indian Ocean tsunami in 2004, with hotel visitors, caught off guard, not knowing what to do. Famously, a young student who was visiting from Sweden had learned about the signs and saw what was happening and warned and contributed to saving many, many lives. So I guess if we just strategically place foreign smart students at all our hotels, that could be a solution. But of course, educating our own students to, and so forth. So, but maybe they're not regularly staying at those hotels. So thank you, Anne, for that question. Todd or Jay, anything to add on that?
Oh, I gotta unmute. I would just say, yeah, thanks, Mark. You covered it. Yeah, it is definitely one of those areas we're constantly trying to do more outreach because those are some of us live in tsunami hazard areas, so we're more familiar with them, and it's the people coming in that may not. And that's also one of the things we work with our local communities to try to install kiosks in public places that often explain the tsunami hazard and show the local tsunami maps with tsunami evacuation routes. So that's one of the things our program work with a lot of our local coastal counties and cities to get those installed throughout the state as we can.
All right. And then, Anne, I see your follow-up point about doing one specifically, a webinar specifically for the hospitality industry and requesting months of notice to get the word out to your groups. And so I've noted that and we'll follow up. And then let's see. There's a comment from Helen Miller. It's really long in the Q&A. But So unlike other watch warning protocols, such as for hurricane or tornadoes, where there is a watch shoulder area immediately adjacent to the warning area. And this, so people, so people who are driving directly into the warning area might get notified. In this case, only the warning area was notified. And um, uh, Todd, I know this was, and Jay, I know this was there is a big difference between tsunami warnings and like hurricane warnings, where there are those kind of warnings and watches all at the same time. You want to say anything about that distinction and what?
So I answered one of the questions about the procedures, about WEA, what triggers WEA and that sort of thing. I sort of answered that and so I'll bring that up, that there are multiple. So the National Tsunami Warning Center, who is our California, they're our source for information about tsunami alerts. We do not want to confuse that with the Pacific Tsunami Warning Center. So the NTWC has a procedure manual, and there are multiple pathways of getting tsunami information and converting that into an alert level, whether it be a warning, a watch, or an advisory. And in this case, the procedures led them to announce a warning with the so-called shoulder areas. So only places that were within 250 kilometers, where breakpoints were within 250 kilometers, were put into a warning. But the places beyond that were not put into an advisory or watch. Do you have anything to add, Todd?
Thank you, Jay.
Yeah, I guess, well, I saw there was also a follow-up question. I mean, kind of on the similar line about the over alerting with that. And so what I talked about, like a lot of the, like, right, if you had to do a word cloud, from a lot of the feedback we got from that event was, that would pop out in there, is that countywide warning is problematic. It has been an issue, and also some of the language in that warning. And the short answer is yes, these are things that we've had multiple discussions with the National Tsunami Warning Center and the other state territory partners with them about, and they are working to try to address that. There's just some, systemic computer, issues, or, like technological things that are a barrier to getting that kind of those more fine-tuned alerting areas. But that is kind of top of the list of things that we are all requesting to be refined, hopefully prior to one of the next alerts. But that's also why, we're really pushing that, knowing the tsunami hazard area zone, because right now, as it stands, if we had another tsunami warning right now, it's going out to the entire county. And so we've been working also with our local counties to kind of have follow-up messaging as best they can. But some of the other messaging we're telling people too is that this event, fortunately, was not impactful, but right, we got lucky with that. But that's why people really need, if they get that, they need to know their zones and know if they're in the tsunami hazard zone. And if you get that WEA, not expect the wireless and emergency alert, not expect any other messaging, and evacuate, and that's where we kind of do that when in doubt, drill it out. Because, right, the next time that wireless emergency alert for that warning may be because there's an impactful tsunami coming your way. And we won't know, especially for these locally sourced ones, we won't know that it's truly an impactful tsunami until those waves are hitting the local shorelines.
Thank you all. So there are a few more questions that I would ask Todd and Jay. I think Jay's already on one to respond via text, so we can move on to our next presenter. So definitely look in the Q&A section at the top of the window that pops up. You'll see an answered tab, and you can look at that and for those answers. But let's go ahead and move on. And let's see, Dina, you're up to introduce our next speaker. Thank you, Todd and Jay.
Thanks, Mark. Thanks, Todd. Thanks, Jay. Great. I also dropped in the chat how you can get alerts for throughout the Bay Area. Our CalOES website actually has it for all the counties in the state as well. So please be sure wherever you live, work, or play, it's really important. Or where you drive through to get to those places. If you're driving through hazard zones and things, please just be aware of that. Great information. Thank you. Yeah, we dubbed our tsunami luncheon that day. We had emergency managers at all in one place at one time. It was quite impressive when all of our alerts went off at the same time. So, but we got them, to your point, Todd, which was great. I have the pleasure of introducing our next speaker. Dr. Curtis Baden is a research scientist with the U.S. Geological Survey who applies geologists' perspective to geophysical problems. His work integrates field observations and laboratory analysis with numerical modeling to investigate the mechanical behavior in an elastic deformation of Earth materials. That's a mouthful, Curtis. That's great.
My apologies on that.
No worries. I love it. Curtis also specializes in shallow faulting and near surface deformation with a focus on how these processes influence earthquake hazards and impact our infrastructure and population centers. So with that, Curtis, please, you're up.
All right, sounds great. I am excited to share today's quake break today. So let's jump right in on recent earthquakes in the San Francisco Bay Area and beyond. So I am part of a team of scientists here at the U.S. Geological Survey, or USGS, and I work at the Earthquake Science Center, which I'll term ESC. Here at the ESC, we do a lot of scientific work related to all facets of earthquake science. That ranges from network monitoring of actually monitoring our sensors to understanding how the crust moves during earthquakes, and of course, earthquake response and disseminating products to the public. All of the work that we do as earthquake scientists really informs some of the product or the hazard and life safety products that are available to the public on the USGS website. And I would like to note that all of the information that I'm going to share with you today is available on the USGS Earthquake Hazards website, which I'm happy to pop into the chat right after I'm done here after this quick presentation. Ooh, there we go. Okay, so without further ado, let's talk about recent earthquakes ranging from December 5th to February 28th, which was last Friday. That's when I made the presentation. Globally, we have earthquakes above magnitude 3.0. We had 4,725 of those in the last few months. They all occur, or not all, but many of them occur along plate boundaries, which Jay talked about, denoted in red lines here. Above magnitude 5, we then had 427 of those earthquakes. And if we look at large earthquakes above a magnitude 7, there were 4 of those. Now, if we zoom into California and Nevada, and again, these are earthquakes queried off of USGS's website. Above magnitude 3, there were 236, and these are all denoted by these little circles, where the color of those circles denote when that earthquake actually occurred. The gray ones here are older than a month ago. Many of them correspond to that Mendocino event. Above magnitude 5, there were 3 earthquakes. There's one in Nevada and then 2 up again in Northern California. And above magnitude 7, there's the offshore Cape Mendocino earthquake on December 5th. And I'm going to focus on this earthquake for a few moments because it was large enough that it generated a lot of the hazard products that we at the USGS produce during significant earthquakes. I want to start with Shake Alert. So Shake Alert is a program that is designed to disseminate early warning information to nearby population centers. And the way this works is that when the fault ruptures and that energy irradiates away, the sensors closest to the fault detect that energy radiation, and they can broadcast that information farther away to centers that are farther away from the earthquake source. So since data transmitted electronically travels farther than earthquake waves, you get a delayed warning, a warning that comes in advance of the earthquake wave, and your warning time depends on how far away you are from the actual earthquake. So for this event, this is the shake alert response. We see shaking intensity shown here on the left-hand side, where those yellows, oranges, and reds correspond to high shaking intensity up in Eureka. And on the right-hand side, we see how that alert was disseminated. So that red circle shows the front of peak shaking during this earthquake that radiates out in a way after the earthquake occurs. And that's at t=0. So each of those coincident circles outside of that red circle show how much time people had before the peak shaking arrived after they received the alert. So if you're inland on that second concentric circle, you got 20 seconds of warning before the earthquake shaking struck. This earthquake was predominantly a strike-slip earthquake. It had a hypocenter of 11.5 kilometers deep. That's about 6 miles. And this is information that we produce for most earthquakes, pardon me. And this is the shake map associated with this earthquake. So warmer colors, or the oranges and reds, correspond to high shaking. Those blues are lower shaking. See here's some of the other products that are generated. So this is called PAGER, Prompt Assessment of Global Earthquakes for Response. And these assess immediate earthquake impacts for responders, agencies, and the media so that they can understand what the impact was of an earthquake in the United States, and then also for earthquakes that occur abroad. So in this case, estimated fatalities got a green ranking. This was not expected to generate many fatalities. It occurred offshore, and there were some resilient infrastructure built around that. But it did generate a yellow alert for economic loss in the 10 to 100 millions of dollars of loss for this case. And you get this information very quickly so that you can respond. We also generate aftershock forecasts. Now, an aftershock is an earthquake that occurs after the main shock. And these provide communities with probabilities of short term, in this case, 1 month. How likely is it that you will have an earthquake of a given magnitude in the next month? So for a magnitude 4 in the next month after the Cape Mendocino earthquake, there's a 44% chance that that is going to occur. And that just gives you a sense for what type of earthquakes you might expect. And finally, Jay talked on this, or talked about this a little bit already, so I'll skim over it. But this is just these hazard maps associated with landslides and liquefaction that highlight areas of particular damage so that emergency responders can respond and dedicate resources to those areas highlighted in those cyan circles. And finally, the did you feel it response. So this shows that the earthquake shaking was felt across Northern California, Southern Oregon, and Western Nevada. And in the event of any earthquake, if you feel it or not, we encourage you to fill out a Did You Feel It response form. These are available on the USGS website. Again, I'm happy to share that link afterwards. And these responses help inform us and our models for seismic energy radiation and ground shaking. And they can also help us, even if you don't feel an earthquake. That's an important data point that lets us know that you didn't feel it, and that is important for our model. So even if you don't feel an earthquake, let us know it's important data. Finally, I want to focus now into the Bay Area specifically. So these are for earthquakes in the Bay Area greater than magnitude 3. There were 17 of these in the last few months. The largest event was a 3.9 near Tres Pinos, California. And this is the Did You Feel It map for that event. So we can see that these little squares correspond to fairly low shaking intensities. Very little shaking was felt in the immediate Bay Area, but there was moderate shaking felt to the south near Salinas Valley and to the east. So this is this graphic serves as a reminder that we live in earthquake country. So this highlights the major faults in the San Francisco Bay Area, and this shows the probability of earthquakes of a certain magnitude occurring on one of these faults in the next 30 years. So for a magnitude 6 or greater event to occur in the next 30 years somewhere along one of these faults, there's a 98% chance that that will occur. For magnitude 7 or greater, there's a 51% chance to occur. So it is always important to be prepared and to know how to prepare yourself and your household and your community in the event of an earthquake. If you feel shaking, or if you get a shake alert related alert, it's important to drop, cover your neck and head, and hold on and move to a covered area, and then respond after that. So with that, I'd like to thank you for your time. Happy to take questions if there are time, and I can also respond in the chat. Thanks.
Great. Thank you, Curtis.
We do need
It's
to
always
move along.
impressive how many we actually have, right?
Right.
Okay, Jeff, if you could introduce our next speaker, please. Thank you, Curtis.
Yes, thank you. Thank you very much for that. And it is my honor to introduce to you Steve Torrance. First, I want to say, Steve, thank you so much for bearing with us these past few months. We actually tried to get a date time for a workshop in person, but Steve's been very gracious. Steve serves as the Marin County's Director of Emergency Management within the Fire Department, the Office of Emergency Management. As the director, Steve oversees the county's Emergency Operations Center, Alert Marin and Ready Marin programs, disaster planning and recovery. He brings more than, excuse me, more than 10 years of emergency services experience to the county of Marin. Director Torrance holds a master's degree in emergency and disaster management from Georgetown University. Prior to serving as Marin County's director, Steve formerly served as the Emergency Services Administrator for the City of Santa Monica and Area A Disaster Management Area Coordinator in Los Angeles County. Stephen also led or coordinated emergency operations for multiple responses, including wildfires, tsunamis, heat events, civil unrest incidents, infrastructure failures, aircraft incidents, and large-scale planned events such as presidential visits and the LA Marathon. So it is my pleasure and honor to welcome you, Steve. Thank you so much for being with us today.
Thank you very much, everyone, and good morning. As Jeff was mentioning, I would have loved to have everyone up here to Marin County. It makes a great opportunity for us to not only see the county, but enjoy the good parts of the Bay Area. The entire Bay Area is good. And so with that, thank you for the opportunity to be able to present. I just want to confirm that everyone can see my screen. Maybe a thumbs up from.
Yes, we can see it.
Perfect. Well, thank you very much. The previous conversations with from Cal OES and USGS definitely linked to this presentation. We on December 5th, not only did we go through the same event, but we had an opportunity to exercise our plans. And so I just want to kind of kick us off with where we are. This is Marin County. We are one of the least populated counties with about 230,000 people in our 250,000 people within our county, where there's multiple cities that are in the Bay Area that have more people than us. But with that, we have a lot of hazards, and we primarily focus on wildfires here in the county because we have a high fire severity zone. But at the same time, we have a lot of impacts from other emergencies such as tsunamis, which I'll speak to primarily, but also earthquakes. Our county is split pretty much in half by the San Andreas Fault. And we've had significant impacts from the 1906, which was just, I believe, just celebrated the anniversary of that. But we've also seen multiple impacts from these types of disasters within our community. Most notably, the 1906 earthquake out in West Marin split fences on properties more than 16 feet in certain locations, and you can actually go out there and see that today. The National Park Service actually has an earthquake tour that you can go and walk the San Andreas Fault in our community. We've seen significant rail damage, significant house damage. With all of the things that impact our community. And so although our office is within the fire department, we also need to make sure that we are going through and finding better ways to tell our stories about the hazards and the risks that are in our communities. Right now, we are 100% focused on mitigating our wildfire risk within our county, but we cannot neglect and nor forget about our risk from wildfires. From earthquakes and tsunamis. And so just our risk throughout the county, with our last hazard assessment for the county, out of 18, we have a number of threats that impact our county: flooding, erosion. Tsunami is also ranked 15 out of 18. Earthquake 15 out of 18. But we also look at sea level rise and wildfire. And so this has to be one of those, all hazards approaches to making sure that we can go through and understand our risk throughout the Bay Area, but specifically Marin. And so for today, I want to focus a little bit on what you guys have been hearing from Cal OES, USGS, that 7.0 earthquake that for us, I call it near source, local source. I'm not familiar too much with the terminology. All I know is it was close. And so with that, for us, we got the National Weather Service wireless emergency alert, and I'm going to focus in on some of the actions taken and how we have to actually respond to that on the county level. For us, we got the origin time around 10:44 in the morning, and that tsunami bulletin came out about 5 minutes after. With that, every jurisdiction, as you heard, those countywide alerts that went out hit our phones within Marin County about 10:50 to 10:55 for people who were actually in the county. And that warning was at Act Now. And so for us at the local, county and or city level, that was the same time we got it. And so with that, we had to prompt our response at the same time that people were, getting those notifications from the community or within the community asking us what to do. The National Weather Service, and I know the Cal OES team, they were speaking about how the improvements, are happening. For us, we had people that were on Mount Tam, which is about 2,000 feet in the sky, getting a notification that says, go ahead and, evacuate to high ground. And, for us, we want to figure out how can we make that a little bit easier. And so our duty officer received that notification, and part of our structure is to make sure that we can localize all alerts. And that's part of our playbook, not only if it's something that's sent out from the state or from the federal government, but we want to make sure that we can localize that information. And so we have our playbook that identifies what our next steps are in the event that a jurisdiction outside of the county sends a notification into our space, but also activating our local emergency operations plans, which for us, we focused on the maximum threat because of the impact. And I forgot who just mentioned it, but San Rafael on the bay side of Marin County, a lot of our infrastructure is actually in inundation zones. In addition to what we have here, we actually have Highway 101, which is our sole freeway that goes through the county. Significant portions of it are underwater in certain locations. But in addition, we have our bedroom communities where we have Tiburon and Belvedere, where a lot of our streets, one way in, one way out of these communities, are also in some of these inundation zones. In addition to that, a lot of our public safety infrastructure, so our fire stations, our police stations, schools, hospitals, all of these things are at sea level for us. And so when we do have these potential impacts from tsunamis, there is a real threat to our community. In addition, on the ocean side, we have Stinson Beach, where this is not necessarily, it was a bedroom community. Now it is an Airbnb slash VRBO community. So there's a significant amount of people, where I believe about 70% of the homes on the Stinson Beach Isle are short-term rentals. And so we know that the people that are in this location along the beach are not from Marin. They're visiting from out of the state. They're visiting from out of the country. And so it adds to another layer for us to be able to make sure that we're doing effective alerting. So some of our internal actions is we knew that we had this alert that came in, but we wanted to make sure that we understood what should we do. And so as mentioned, that National Weather Service notification went out, and we launched our localized countywide Alert Marin. And so with that, we ran into a situation where we had to ask ourselves, do we send a WIA to follow up? Or did we send out a text message, email, and phone call? Because of the wireless emergency alert going out and us not knowing if this was a real event, we opted to not send out a WIA so those systems didn't step on each other. And with that, we sent out our Alert Marin about 11:19, and we scheduled an operational area call because our partners were calling us going, what do we do? And for us, we were talking with the state, but also we were talking about with our regional partners in the other counties along the Bay Area. And with that, we had our opportunity to go through and talk with all of our operator partners to make sure that everyone knew that we weren't evacuating into a different county and vice versa. But we also started hopping on the call with other counties, the state, to make sure that they knew what we were doing as well. And so that supplemental Alert Marin message that we sent out, for us, we send out everything in English and Spanish to make sure that people knew what time it was expected to arrive in in Marin County, but also making sure that people knew where to go in the event where we have a lot of harbors and low-lying areas. But for us, the most important thing was the link at the end of this, which took people to the maps that I previously showed. That way, people got a chance to see where they were in relation to that tsunami inundation zone, to make sure that our messages that were sent out could at least provide some more direction. As we don't have, with us having the countywide lens, we don't have signage in all cities, but the cities, we wanted to make sure people could see where that inundation zone was countywide. For us working with our school districts, fortunately, I'm not sure. A lot of our school districts have schools that are oceanfront property. And for them, a lot of the schools went through and evacuated their students in accordance with their local plans, which is awesome. With that, we wanted to make sure that we could get in contact with them the same way we were getting in contact with our cities and towns as well. And also working with our air assets to make sure that, as I mentioned, we have a large portion of West Marin, generally unincorporated, mostly rural areas. And so the only way that we could really do evacuations in that area were to go through and actually use helicopters and the speakers that were on those for those areas. Our partnership with Health and Human Services as a county department, leveraging their capacity to reach out to hospitals to let them know, hey, yes, this is something that is happening, but also coordinating with them. Luckily, we don't have any hospitals in the inundation zones, but giving them a heads up that this might be something where we might have to activate an MCI, or you have a lot of patients that might be coming because of the areas that we have. So some of the challenges, there were a lot. There are a lot of lessons learned. We have our after action report that we put together also with our county partners. We have a lot of maps, and sometimes they are a little generalized, and we're looking and going, so is this going to go all the way in, or if this is something that's going to just be just along the coast? We weren't sure, but it was just because the amount of information that we can get in that short amount of time. And so those were definitely challenges. Also, the location, the tsunamis that we've historically had have had hours for us to, come across the Pacific Ocean. And so this presented a unique challenge because it was a couple of minutes away. I believe it was, less than an hour before it was projected to hit Marin County. So that allowed for us, we did not have that much time to ask questions and get clarification. There was a lot of situations where we just had to act on the best information that we had, which is not a problem. As long as you can stick to your plans, you can use your best judgment on the information. It really didn't allow for us to wait and confirm, but as long as we could defend our answers. So some of the things that we've started to talk about with our partner agencies is, we within the county, we are working with Cal OES as well, as we want to know more about these near source, local source tsunamis, and how can we improve our plans to make sure that in the event that we're flying by night, and we have to go through and do our, make our own decisions, making sure that our plans reflect the best practices in that space. Also, the impacts on our counties based on the source location. The western portion of Marin County, it actually splits like a V. And when we see that, we don't know if there's a possibility that that wave could actually funnel into our Tamales Bay. And so that's some of the things that we're looking to see if there's some more research that we can go to understand that for our West Marin community members. We also have we want to do additional research along the Pacific Rim, as Curtis was just mentioning. 4,000. I don't know how many of those were actually along the Pacific Rim, but when we start looking at our maps, how do we figure out if something that happens along the Aleutian coast or versus Peru, how does that affect our county? And really figure out how we can get complete data in that space to enhance our community materials. Some of our response challenges, when we start looking at this, the local agencies were all coordinated at the same time. We have an unhealthy amount of fire districts within our county with all very specific areas, and we needed to coordinate with all of them. And so with that, we have our duty officer that's 24/7, but that person can only pick up so many phones at a time. And so, for us, it's making sure that we're sharing information quickly, but describing as much as we can with maps and pushing out materials, because we know that the community members are actually calling into 911 to ask, well, am I in the tsunami inundation zone? And so we want to be able to push them to specific area to say, here's the map, here's the information available to you. But we also recognize that there was some infrastructure capacity issues, cell towers, all of these things. As I mentioned, we had to make a decision about whether or not we were going to do a WIA versus a text message, and we made the decision because WIA had already gone out, and we wanted to make sure that we could continue to go out. The next message could go out. So some of the improvements that we've made since, this is a great opportunity to connect with your partner agencies. The Bay Area counties and OAs, we've gone through and started talking a little bit more to make sure that we can coordinate better, specifically on these widespread incidents where it's not just one county. We're good at that, but what if it's multiple counties with all of the same thing? We're all pulling from different, we should all be pulling from different resources. We can go to the Northern California, the other Bay Area counties can go south. But also looking at our unified alerting systems. For us, we recognize that us having the pleasure of serving as the countywide alert and warning coordinator for our county actually did us a benefit because we didn't have mixed messages going from different agencies. We had one message going out, and it supplemented the things that were coming from the state and federal partners. But also it drove a lot of our partners to go through and improve our plans. Just some high level data points. I'm not a data nerd or anything like that, but I'll do my best. This was our largest our largest alert that's been sent out in our county's history, where we sent notifications to over 1 million points of contact. As I mentioned earlier, we have 250,000 people in our community. And so on average, every person that lived work, we've done some informal polling. Every person got some type of notification from our office in addition to the National Weather Service. And so, it validated our systems, it validated our capacity. We got 564,000 phone calls distributed. And then on our website, people that clicked that link at the end that said marinoem.org to go to that map, we had 26,000, just shy of 27,000 people go to that page within the first hour of the incident. And so for us, it's making sure that we have information available in the event that the community members need that. Last couple of things, never waste a good opportunity to inform your public. That same day, we sent out a notification reminding people, hey, this type of thing does happen in our community. We shared it on all of our social media platforms. We explained what happened and why it happened, because we wanted to make sure that people didn't just think that we all messed up. We went through and we shared that information. This is why we made the decisions that we did. But also some of the analytics on the back end, sharing it on Instagram and having that moment to talk to the community was important for us because we realized that most of the people that followed and shared our stuff were not following our account the day before. And so it was an opportunity for us to gain those followers, but also we realized that people were sharing the content, and actually learning from it. And so, the after action report, some of the high level things, better localized messaging, more public maps to make sure that people know where they are. We've gone through, we've recognized that although we got just over 1 million people to be alerted, not that many people are opted in. We used all of our emergency data. And so we are pushing this to our community members, and they know now, hey, we need to reinforce this to be able to localize those messages. But as I mentioned, we are wildfire prone here, and we need to consistently prepare for, earthquakes, tsunamis, all these untraditional to Marin emergencies to make sure that we can keep our community safe. Just to close, as I mentioned, come on out to the Earthquake Trail. It's the western portion of Point Reyes National Seashore. This is a photo I took. You can actually walk the trail, walk the San Andreas Fault. Not only is it beautiful out there, but there's also a good opportunity to see the power of the Earth and how things can be moved, and the different things that happen not only in Marin but throughout the entire state. So. With that, thank you very much for your time. Hopefully I didn't fly through that too quick, but open to any questions along the way. So thank you.
Thank you, Steve. We have a couple questions related to your talk and some others also in the chat that I think are being answered. One was directed to Dirk from FEMA, and there is a response that Dirk added, I believe, to Anne's questions. Um, one question asked during your talk by Leah, what is MSI? If I heard that correctly, as she said, might you know what she's referring to?
I don't think I said MSI, but if I did say an acronym, I apologize.
I think it was mass casualty incident.
Oh, MCI. Sorry, yes, mass casualty incident. So for our hospitals, anytime where there's more than 4 patients, we try to give them a heads up that heads up, you got more than 4 people coming to you, tied to one single incident. And so we'll go through and notify our regional partners. And that number, I believe, can fluctuate depending on the jurisdiction. So San Francisco's MCI level might, be way more than 4. I'm not sure.
Stephen Ron Hogg asks, what type of education outreach are you doing for groups such as group homes for people with disabilities, senior living facilities, the homeless, and also transportation needs? That's a big area and a long answer you could probably give. What's the how did maybe related to this incident? What type of work was done?
Yeah, we have invested a lot of money into our Ready Marin program, and the intent of this program is to reach out to those specific communities to not only learn how we can improve, but also inform it as well. And so our human health and human services team, they help us with the group homes, the skilled nursing facilities, the SNFs, and things of that nature. But we have unified messaging where they take that from our office and they provide that to the people that live at those facilities, the business providers and such. And I'll focus lastly on the unhoused community. Throughout the state, we have a lot of unhoused persons, and a lot of them do reside in the lowest lying areas of our community. And so part of our Ready Marin program is actually going out with our homeless services team to learn about the challenges that our unhoused community may run into, but not make assumptions. And so we're sitting here going, hey, we might assume that people don't have cell phones, but now we know that a lot of them actually do have cell phones. And so we're actually working with our unhoused community to get them signed up for Alert Marin, with the carrot that we're saying, hey, we send out our notifications for our severe weather emergency shelter through that system. And so there is an incentive for them to want to sign up for that system beyond just emergency alerts, but also making sure that they know why we have these systems. And so our readymarin.org page is a pretty robust page. We focus on our different languages. We focus on access and functional needs primarily, but we really want to make sure that we're having a whole community approach with our messaging.
All right. Lars Eric asks, is Marin County a user of Genesis Protect, formerly Zone Haven?
So we actually have a lot of different systems. So we actually have Everbridge, we have Genesis, we use primarily Zone Haven. We also have LRADs within our community. Those are the outdoor speakers. And then we also have the state's rave system. And so I like to say that we're a power user of alert and warning within our county. We primarily use our Alert Marin system is primarily serviced by Everbridge. But with that, we have redundancies with different vendors.
Great.
And part of the reason I asked that is because City of Berkeley used that to indicate the zones they had to evacuate. So I don't know that you guys did that.
Yes, and so because the zones that are in Zone Haven don't necessarily align with the evacuation zones for tsunamis, what we did is we actually turned on the layer that actually had the tsunami inundation map clearly. And so we didn't necessarily light up the specific Zone Haven layers, but we did make sure that there was a layer available to the community.
Awesome, thank you.
Finally, from David Fang from Berkeley, OES, does Marin have a spreadsheet identifying critical infrastructure facilities that are within the tsunami inundation zone, and how are you gathering that data?
Yes, so part of our hazard mitigation plan is we go through and we actually work with all of our cities, towns, and special districts to get that information. We actually have an internal situational awareness map where all of our critical infrastructure, whether it's privately held or owned by a public jurisdiction, we have that on a map, and we also have those individual locations in our alert and warning system, so we can send them out a specific notification to all of our critical infrastructure partners. So it is not something that we put public facing, but we do have that available with our duty officers.
Jay, your comment that you just added in the chat, I think maybe you want to say a little bit more than that because it may not be what people are considering in terms of the difference between inundation and hazard.
Okay, yeah, fine. So I am glad to elaborate. So the state tsunami hazard area maps are evacuation maps. They're not inundation maps. And so I just want to help people, sort of like learn about that a little bit. It's not that big of a deal, but technically they're not inundation maps. And so basically what we did at CGS is we took the tsunami model, in most places, the 1,000-year tsunami model, and we used that to generate an inundation area. And then we extended the boundary of that inundation area to geographic features like roads and other easily identifiable features. And that is what the tsunami hazard area maps are. So they're larger in size, they're more conservative than what we think might get inundated during a tsunami. So it's a technical, distinction, but I thought this was a great opportunity to explain that.
And even still, in some areas, the mapped area may have reduced, gotten closer to the coast, but other areas it may have increased. So definitely looking at what the current map is important. You may have in your plans outdated maps of what to consider. So thank you, Jay, and thank you everybody for all the good content. We're going to move on. I just want to share this that we do have a survey. We put links in the chat. You can use your mobile device to just scan the QR code here. If you've been with us before, it's basically a similar survey as you've done before, but we do ask that you do that so we know how this went. And also you're asked for your ideas and comments for future events and how you might want to participate with us. I'm going to just jump into slides that are a little bit behind and quickly. Just FYI, what SCEC is we're the kind of the administrative home of ECA, formerly Southern California Earthquake Center, kept the acronym, changed the name, Statewide California Earthquake Center. We've been doing work statewide, both on our science and our education outreach through ECA for many, many years. So it's really just caught up finally our name. And we study the plate boundary between Pacific North America plate from south of the border to Cape Mendocino, which we've heard a lot about today, of course, where the type of plate boundaries change. But there's a lot of similarity kind of throughout the state, and bringing together everybody studying the fault system as a whole is always better to have that broad perspective. For ECA, our website, we also have a website in Spanish at terremotos.org. We support Tsunami Preparedness Week and, of course, Shakeout, and you can find out our events on our calendar. We do have sector-based outreach committees that you're all encouraged to be a part of. If you're not currently, we are kind of building these and to have quarterly meetings throughout the year and take actions and be at events and do webinars kind of in between. So it's not a lot of work, but we want your input to developing the materials and resources and activities that we do. And of course, our regional alliances do either like today, either online, but we're trying to be as in person as we can. Bay Area has been doing a really great job with this throughout the last year or two, coming back from COVID, and also can be at regional activities. We have a request form at earthquakecountry.org/ECA-events. If you would like speakers at your event or to come speak to your organization, your community, or if you're having a preparedness fair, and probably some of you have requested such things, and we're hopefully I've been able to provide people for you or at your upcoming activities. And all of our messaging is really framed around the 7 steps to earthquake safety. Really what we encourage all of you, if people ask, what do I need to do? This is a good kind of organizing structure to send them to earthquakecountry.org/7 steps. And what we're seeing here are kind of graphics showing people doing the different actions, from securing your space so things don't fall, person kind of drilling holes into the wall for straps secured to a bookcase, people having at a table, having conversations about how to communicate and what their plan is, and including someone who is in a wheelchair. So we have a lot of guidance for people with disabilities and access and functional needs throughout these resources. And then organizing supplies, someone putting things into a book, sorry, a backpack, and but then also how to minimize financial hardship. So putting your documents either into something that bring with you, a document holder, into the cloud, and maybe even retrofitting your building foundation or otherwise to reduce losses, considering insurance, etc. During the earthquake, step 5, what we say, drop, cover, hold on, or adapting that, perhaps lock your wheels if you use a wheelchair or a walker with wheels, to lock, cover, and hold on. And then afterwards, to improve safety, you're going to be assisting those with injuries. You're going to be turning off the gas, or maybe using a fire extinguisher to put out small fires, sweeping up broken glass. That's kind of the image depicted there. And then afterwards, reconnecting and restore, getting back together, kind of rebuilding and having those important discussions as a group. We have this guidance in 16 languages across about 15 different documents you can find at earthquakecountry.org/languages. A key document we have is how to secure 8 common household or even workplace items, such as bookcases, water heaters, kitchen or other cabinets, your small items with earthquake putty, just a lot of very simple diagrams and text instructions that go along with that. We have a disaster supplies checklist for step 3 that talks about what you can have in different locations, your basic home supplies for maybe for a couple of weeks, a go bag that you would bring with you if you have to leave your home, what you need if you have to be on your own for 3 days, your important personal items. Don't just use a bag you bought of an earthquake kit. Make sure that you supplement that with your own prescriptions and other things you need. The under bed bag is not a go bag. It's a get up out of bed without cutting your feet up bag, and being able to find your flashlight and your glasses. So you put those items into a bag that you then put under your bed, tie it to your bed so that as things moving around, as glass may be breaking, the first thing you do is pull that bag out, and because it's closed, glass didn't get in your shoes, so you're not even putting your shoes on and stepping into broken glass. So it's a very basic thing you do once, and then you're done for until that earthquake happens and you need it. And we have guidance on the step 3 page about that. We do have a mini awards program. We're going to be having for applications for 2025 coming up in April and May, where you can request, put in a very simple proposals or requests that we purchase items, probably $500 in some cases, can up to $1,000 for earthquake mitigation and education activities. And you're able to customize exactly what you need for your own location. And it could be for your own location. It could be for somewhere else that you're helping get more prepared. Of course, Shakeout happens each October. This year it's going to be on October 16th, always the 3rd Thursday of October. And importantly, we always have a Shakeout Day media event. And we are, last year we were at UC Berkeley. I saw Jason Ferguson from UC Berkeley. I don't know if he's still with us. The emergency manager, fairly new there, and helped organize a great event. Thank you, Jason, for the campus and for the news media. And we are looking at a Bay Area location that for a real drill, real exercise. This could be something that you host to highlight what you're doing for Shakeout in your day activity. We would come even earlier than probably we'll be starting to have interviews in the big Shaker earthquake simulator for the local morning news, and then continue into your exercise. So if you're interested in that, please do reach out to us, because we want to start planning that very soon. As far as we heard a lot about tsunami today, at tsunamizone.org is where, kind of like Shakeout, you can learn about activities you can do. You can register your activity, and we're hoping to get to over the course of the year, but especially during Tsunami Preparedness Week. But anything you do for tsunami preparedness, it can be registered, get on our email list, getting updated guidance and resources. So I hope to get to 500,000 this year. We have a lot of resources in graphics and tools that you can use and that you can download from the webpage, including a new document holder that is kind of has a list of what to put in it, and it can be somewhat sealed up and put into your go bag. We have bookmarks and we have luggage tags for your tsunami go bags. We have guidance on how to participate different ways, and because it's not like shakeout where kind of everybody mostly does either drop curve hold on or lock curve hold on, like a 1 minute drill. It's not, everybody is not right next to the coast where you can do a test of walking your evacuation route. So we kind of expand what you can, that is considered as part of tsunami preparedness, even sharing information with others. And the key thing is, as we learned in the December 5th earthquake, we need to be educating everyone about tsunami hazards, not just those that are in the tsunami hazard zones, because the message went out. People were in danger when they were at the top of mountains and really weren't. So they need to understand the importance of knowing your zone, knowing where the hazards are, and making sure that people who might not live or work near the coast but might visit at some point, which kind of can be almost anyone, knows what to do if they were there. So that's all part of what the type of messaging that your organization, your city, county agency, your business, et cetera, can be doing to encourage people to take some action, to learn something, and to register that activity on the website. It's just like Shakeout. You fill out a form, you get listed at the totals, you get kind of listed by county and by region, and with your option, will list your name of the organization once you click in there further. So, and we also list some events that are happening. So certainly, if you are organizing a public event, we want to know about it. And there's an event calendar on the news and events page of the website, or you can also just email us. Okay, so there's at tsunamizone.california, you'll see tsunamizone.org/California, California specific resources, including a link to last year's tsunami webinar. This year, we're going to have a webinar specifically for businesses, but this could be for all of you because many of you will do outreach to businesses. So you may want to come. We're going to be doing that in partnership with the BICEP, the Business and Industry Council on Emergency Planning and Preparedness. And again, trying to build up our participation, and think about what you might do and register it. Plan to provide tsunami messaging to all your constituents and people that you reach, and I said all that already. So also, you may not be aware that there is something called the Haywired Scenario Exercise Toolkit, and you can find that at earthquakecountry.org/haywired. So it takes the Haywired scenario and breaks that down into 17, but soon three more. We're just almost done with it. Toolkits for different topics that include a discussion leader's guide, really making it really simple to have a tabletop discussion, all the details that you need to do so, as well as a slide set of relevant figures for that particular topic. And also, we are looking for hosts, locations, or groups to provide some trainings with this material this spring. So I'm really encouraging all of you who may want to provide this as a resource to your community, to your businesses, to your agencies, to nonprofits and others. There are ways that they can really consider some issues that will happen in kind of almost any earthquake, using the Haywired scenario of the Hayward magnitude 7.0 as an example. So please do email me at, there's my email address directly if you're interested in having one of these trainings. It's funded through the USGS, and led jointly by myself and Monica Stoffel from the California Resiliency Alliance and Ann Wine from USGS. Finally, you may be aware of our Quake Heroes film, 54-minute documentary from the Northridge earthquake, but really what it's highlighting is how people do and can help each other after earthquakes. Features the 7 steps to earthquake safety. And we're having events with these coming up next week down in Southern California. We have funding from the California Seismic Safety Commission to help organize expos in underserved communities across the state. And we are also dubbing the film into Spanish and Chinese, so it'll be full dialogue in those languages. And if you're interested, you can go to quakeheroes.org and set up a meeting with us to perhaps be one of those groups, or even to just have a smaller screening of just showing the film and maybe a discussion afterwards. Okay, so ran through a lot there. We're right at noon, and I want to. There was a request. We will stay on for a little bit so people can capture all the notes and content from the Q&A section. Thank you, Michael, for that suggestion. And so there is a way that you can save the chat. In the chat menu, go to the 3 dots. You should at the top right of your window, it should look similar to mine, and click Save Chat if you're interested in that. We will be putting today's recording on the website where you registered, so you can be looking for that. Make sure that you're a member of ECA. That way, when we send out notices that recordings and such are available, you'll know about that. And with that, we'll continue with some Q&A. I see, Sheila, you raised your hand.
Yeah. Pictures, not universal. Infographics, silent with screen readers. And what I've been asking around for in the last 15 minutes or so is the assumption that everyone's going to read the chat is also not true, because I'm listening to the speakers, and if I'm listening to the speakers and a screen reader, I can't listen to 2 voices at once. Maybe other people can. Good for them. And I'm saying that because this assumption of the chat being the wonderful end all be all, not really. I never did find the Q&A. They've made Zoom so cluttered that, like, the AI companion that I'll never use is right on the home screen, but the Q&A is buried somewhere under some tab, and I don't know where.
I agree with you on that. It
So,
used to be a kind of a right there in the middle of the menu bar.
well, I'm going to be giving Zoom some feedback very soon, but because our company is actually switching to Zoom, and they can be accessible. They pay attention and they think about it. Sighted people take advantage of their eyes, and they assume that their eyes are their only sense. They're not.
Thank you for sharing
And I get
this
frustrated.
perspective.
Yeah, I get frustrated at
Really
the ends
important.
of these. Yeah, these webinars. The assumption is we'll go through chirp, 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 and what I hear is silence. Right.
Okay, thank you very much for that sharing that. We'll consider how we use all the tools as going forward, and hopefully Zoom may make some solutions to those too. Helen,
One more thing.
hand raised too.
One more thing that I want to be really quick about is, please understand. I'm saying this to myself as well as everybody else. We need access to these maps in other than map form. And I am going to connect with some blindness folks that can actually create tactile maps, but we need to think about actual words. All these maps came from words first. So there need to be descriptions of things. And of course, in as many languages as possible. This is how the access and functional needs community is going to be served, not any other way. I'm in the Bay Area, as many of us are here, and it's a tourist place. People are coming from everywhere. They don't know anything about this place. They don't know what a zone haven is, let alone what a tsunami map is, So, well, unless they come from one. But anyway, I mean
Interesting
that's
perspective on how to, yeah, how and the importance of that and how that would be done. And I'm sure Jay and is particularly curious on that. And his information was provided, sorry, uh, in the chat. I'm just going to read his. Uh,
I need
Jay,
the
can you
links.
just could you state your email address? Because maybe Sheila can
No,
Yeah.
no,
follow.
no, no. So this is why I ask for after action emails. Because I'm not going to trounce
All
all
right.
over a website looking. If
I
I
was
don't know
going to
your
just connect you
website
with him.
structure,
I was trying to connect you with Jay personally to those answers. So, Jay, what's your email address for everyone?
Jason, Jason .Patton, Patton at conservation.ca.gov. conservation.ca.gov.
Thank
And
you, Jay.
and those are
Helen, you
great
have you
ideas.
have your
Those are great ideas about
yeah.
having more AFN friendly information and resources. So we really, really appreciate that feedback. Thank you.
Helen, your question.
I get tired of saying it. It gets grumpy. I'm grumpy.
I understand.
Thanks.
Thank you.
Sorry.
Helen, please ask your question.
Hi there. I'm Dr. Helen Miller. I'm up in Oregon, and I just appreciate your welcoming collegiality to let those of us who share similar risks and hazards with you on the coast to listen in and try to learn from California. One of our new initiatives is we are coordinating a new ham radio net on the first and third Thursdays of each month. I put the information in the Q&A and in the chat. And certainly, if you have amateur communicators in your organization, we really believe in networking and learning from each other, learning from other people's trainings or actual events. So hope you'll take a look and pass that on to your colleagues in the emergency communications side of your organizations. Thank you.
Thank you, Helen. And as on this screen, is there anyone have any brief announcements of things coming up that the attendees might want to know about? And if it's a link to something, you can add it into the chat.
Hey, Mark, Dina, quick question. Do we know when we're going to have the Quake Heroes subtitles or translations
No,
available?
no. Hopefully within 3 months, but the contract is not even set up.
Okay, thanks.
But
We're going to be hosting a Chinese Mandarin cert course starting April 1st for the month of April.
Right. It
So
won't
if
be
anybody's
available for
interested
that.
in that.
It won't be available at that time. And again, in the chat window itself, you should see 3 dots. There's like a more that you can click to download the chat. I apologize, it may vary by versions of Zoom and all like that. Okay, and then just think about, normally we might have you share, but think about something that you learned today, something that you'll do, something you'll use, and importantly, what will you tell others in terms of information they may need and be valued, and try to put things into action. So we're all about. Again, if you could please complete the survey through the link there or the QR code. And just a final reminder, connect with ECA Bay Area via email at bayarea@earthquakecountry.org. And really generally across the state, info@earthquakecountry.org. And we'll turn to our chairs for any final comments and thanks, and then we'll and the workshop.
Well, thank you everybody for being here. This was great information, and please do share with everybody. The more people we can reach, the more people we can save. Thank you.